Hello friends, welcome to Prismatis online class. In our today's class, we are going to look at what dimensional analysis. And the question on the board says, determine if the equations energy equal to what kinetic energy are dimensionally correct or not. FD, product of mass, product of force and distance is known as what energy. Is it equal to what kinetic energy? And that is what we want to solve. Now, how do we solve this? Always remember that you must first of all check for what left hand side. Is it equal to what right hand what side? So if the dimension of the left hand side is equal to dimension of the what right hand side, you can now say that the equation on the board is what dimensionally correct. But if they are not equal, we are going to say that the equation on the board is dimensionally inconsistent, or dimensionally that it is what not dimensionally correct. So okay, now let's go. Let's pick this the left hand side for left hand side. Now left hand side we have the dimension of what FD, which is the same thing as what dimension of what F multiplied by dimension of what D. Okay, remember that this is the same thing. Force is the same thing as what MA into what D. Now let's go where the dimension of mass is equal to what? Dimension of mass is equal to what? M. Dimension of what? Acceleration from our previous class is the same thing as what? LT raised to power minus 2. Close it. And the dimension of distance is equal to what? Is equal to what? L. So having done that, you can now come here and put it somewhere that the dimension of what force distance is equal to what M multiplied by acceleration, which is L T raised to power minus 2 multiplied by what distance L. Close it. Okay, when you multiply this, we have that the what dimension of what FD, which is energy, is equal to what M. L times L will give us what L square. L times L will give us what L square. Now multiply by T raised to power minus 2. You can agree with me that this is call it equation 1. So okay, now let's go for this one, the right hand side. Dimension of what energy, kinetic energy. Dimension of what kinetic energy, mv square into this is equal to what dimension of what 1/2. Dimension of 1/2, close it, into dimension of what m mass, close it, into what dimension of what velocity, all square. Okay, now what do we have? Dimension of any number is what 1. Okay, multiply by what dimension of what mass, close it, and dimension of velocity from our previous class is what L times T raised to power minus 1. But remember that this has what square. Now what do? We have M, this multiplied by this, we have it as dimension of this into what L raised to power 2 to this by a lot of indices, 2 to this by what by a lot of indices. We have it as what T raised to power minus 2. Close it. Now what do we have? We have M multiplied by this, we have M raised to power 1, L raised to power 2, T raised to power minus 2. So, and that is the dimension. So, which is called equation 2. Equation 2. Having done that, you can now say, hence, having done that, you can now say, hence, L, left hand side is equal to what? Right hand side. That is, equation 1 is equal to equation 2, which is what? M raised to power m1 into L raised to power 2 into what? T raised to power minus 2. Is it equal to M raised to power 1, L raised to power 2, T raised to power minus 2? Close it. Now, this is proof. So, finally, you can now say that the dimension of what? FD is equal to 1 over 2 mv square are dimensionally correct. Hence, the energy is equal to what? Kinetic energy, and it is what? Dimensionally what? Correct. Thanks, and God bless you. Remember to subscribe to my YouTube channel, Prismatis Online Class. Follow me on Facebook, the same platform, Prismatis Online Class. Please like, share, and comment. Bye.